Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the velocity of efflux. Now, let us discuss that what do I mean by velocity of efflux. So imagine a container which is having some liquid filled in it, and there is a hole, tiny hole, which is also called as orifice. So there is a small orifice in the wall of the container through which liquid is getting leaked out or leaking out. So the velocity with which this liquid is getting leaked from this orifice is called as velocity of efflux. Okay, now let us derive the velocity of efflux by using the Bernoulli's principle. So we first of all write down the pressure at point 1. So at point 1 pressure will be equal to P naught, where P naught is the atmospheric pressure, and this is the point 2. So if this depth is H, so the pressure at point 2 will be P naught plus H rho g, and this is the point 3. So pressure at 3 will be also equal to P naught, because 3 is just outside this container. So we are applying the Bernoulli's theorem at point 2 and 3. So we can write down that P2 plus half rho V2 square, where I have assumed that V2 is the velocity of liquid at point 2, will be equal to P3 plus half rho VE square, where VE is the velocity of efflux with which this liquid is coming out of the container. Now just imagine a situation in which if we are enlarging this orifice, if we are increasing the diameter of this orifice, the liquid at this point will start to flow out with a greater velocity. And if this diameter is very small as compared to the area of the container, then the velocity of liquid at this point will be very less. So assuming this assumption that the area of orifice is very small as compared to the area of container, so we can say that velocity at point 2 tends to 0. So P2 minus P3 will be equal to half rho VE square, and P2 minus P3 will be, you can see that P2 minus P3 will be H rho g, and that is half rho VE square. Cancelling rho with rho, VE will be equal to under root of 2gh. So this is the velocity of efflux with which the liquid leaks out from the small orifice in the wall of the container. Now you have also seen this formula in one-dimensional motion, and if you remember that this is the velocity of a freely falling object which is falling from a height of h. Okay, so this is exactly same as that velocity. And now if we discuss about the range. Now what is range? So range, you can see that this liquid stream is performing projectile motion, and therefore the distance at which it will fall in the horizontal direction is called as range. To calculate this range, we need to know the total height of the liquid is h, and therefore this remaining height will be h minus h. So if we find out the time of flight of this stream, which means that time in which this stream will touch the ground, so this will be under root of 2 into h minus h by g. And range is obviously velocity of efflux into time of flight. So range will be equal to under root of 2gh into time of flight is under root of 2 into h minus h by g. So range will be 2 under root of h into h minus h. This is the value of range. Now if we discuss a fact on the next page, that if there is a container like that, and this container has two holes. One hole is at this point and another at this point. The total height of the liquid is h, and this is h, while this is also h, and the liquid is filled into this container. So if we find out the range of liquid coming out of these two holes, we can say that the range of liquid coming out from the first hole R1 will be 2 under root of product of this height and this height. This is capital H minus small h. So this is h into h minus h. And R2 is the range of this second liquid. So it will be 2 under root of this height is h minus h, and the height from the bottom will be h. So if you can see that these two range are same, R1 will be equal to R2. So there are two different points in the wall of the container where if we make orifice, then the range of liquid coming out of them will be same on the ground. This is the first logic, and we can easily say that that if we interchange h with h minus h and h minus h with h, then also range remains the same. Now if we talk about the maximum range, so for maximum range R max, so we need to differentiate this range. So R is equal to 2 under root of h into h minus h, and for maximum range dr by dh should be equal to 0. So dr by dh will be 2 upon 2 under root of h into h minus h, and in the numerator it would be h minus 2h, and that is equal to 0. So h will be equal to h by 2. Okay, so this is the height at which we should make a hole so that range is maximum. Now it is very important that how this is represented in front of the students. So please pay attention what I am saying, that the range will be maximum when the hole is made at a point which is exactly in the midway of the ground and the top level of the liquid in the container. So in this case, if the container is kept at the ground itself and the liquid level, top surface of the liquid is at a height of h from the ground, then for the maximum range this depth should be h by 2, and the value of R max in this case will be 2 under root of h by 2 into h by 2. So R max will be equal to h in this case. So this is the value, but if we discuss a fact that if this container is kept on a stool, on a table which is at some height from the ground, then we can say that if, let's suppose, this height is capital H also and the hole is at this point. So first of all, if we find out the range, then range will be equal to 2 under root of h, which is this height, and the height from the ground, which is this one. This height will be 2h minus h. So it would be 2h minus h. So this will be the range, and the maximum range R max can be calculated by differentiating this. So this will be 2 upon 2 under root of h into 2h minus h into 2h minus 2h is equal to 0. So h is equal to h. So again the same result is observed in this case also, that hole should be made at a point which is exactly in the midway of the ground and the top level of the liquid. Now ground and top level of the liquid are separated by a distance of 2h. So for maximum range, the value of a small h should be equal to h, and the value of maximum range R max in this case will be 2 under root of h into h, which is R max will be equal to 2h. So guys, this is very important in this case, and this was the velocity of efflux, and in the next video we are going to discuss the different applications of velocity of efflux and Bernoulli's theorem. Thank you.